My name is Takeru, Director, Digital Transformation Office, Automobile Division, Manufacturing Bureau, Ministry of Economy, Trade of Industry, METI of Japanese government. First of all, thank you for inviting me to such a great conference on 15th Open Conference in Tokyo. And I was also very happy to introduce METI's brand new digital strategy in the automobile industry before distinguished industry leaders and experts participating across the countries. On behalf of METI, I hope a big success of today's forum. Today, we have a lot to cover. And actually, this new strategy came out last month. And you can go to METI's website and download it in Japanese version. And my colleagues worked very hard to translate in the English version. Just came out for today. And my colleague also prepared a very nice transcript for me today. So let me read that. So let me start with a brief background to why we developed this new our digital strategy in automobile industry. Automobile industry has faced a very competitive environment, both in the green and digital aspect. Japan has been worked very hard toward the realization of GX, green transformations. As you know very well, they are very competitive across the world, not only between the private sector, but also the government policy competitions as well. IRA, tax incentives in the US, and subsidies in other countries. And last year in Japan, we also introduced a new tax incentive for manufacturing EV in domestic manufacture in Japan. And also we are strengthening the subsidies for purchasing green energy vehicle as well. So that's happening in the aspect of green transformations. In digital, we are working very hard for the realization of autonomous driving. But also, not only that, with the advancement of digital technology in the automobile industry, digital transformations has been now becoming a major axis of global competition as well. So here a quick overview of what is happening in the digital transformations. The first, SDVs. Well, everyone here knows very well, maybe better than me, but Tesla brought out its first autopilot, implementing software update capabilities via over the air. They have been working to bring software and hardware development in-house, which was initially left to the partner companies. In addition, the trend towards intelligence car is leading the way in China. And high-performance voice recognitions and over-the-air is installed in the many vehicles now. Although their technological capabilities are behind top manufacturing in some areas, both software and hardware are present. They are promoting development, aiming at in-house production in China. As a result, competitive-related companies are beginning to emerge. From user perspective, especially for younger generations, it seems to enjoy SDV, which enable them to customize features and new services. And second, it's the middle of the slide, autonomous driving in Mars. In the US and China, robotaxi already started its operations. Well, last year, I actually visited San Francisco and Beijing a couple of times to ride Waymo and Baidu robotaxi, which were very impressive. On the other hand, in Japan, last year, in May, in Fukui Prefecture, it's a first level 4 project. It's automated mobility services started its operations. It's near a very famous temple in Fukui Prefecture. And the third one is data utilizations that transcend corporate boundaries. It also have huge impact on the automobile industry. In Europe, there is a data sharing system, so-called Catena X. I will explain it later. And they are starting combining with regulations trying to export electric vehicles. So this is a kind of a motivation to develop our new digital strategies. We share with industry leaders in Japan, sharing the sense of urgency that in terms of digitalizations, Japan is lagging behind. Recently, it's an investment into the SDPs. Recently, including Japanese major OEM, they are accelerating huge investment towards digitalizations, including the SDPs. For example, Toyota, they decided to invest in $1.7 trillion for their Toyota's SDPs. And others, like the Honda, last month they announced 10 trillion yen over the 10 years investment for SDV and electrifications. And so, as you can see the number, SDV needs a lot of investment. So this is another background to develop our new strategies. This is why we need to identify which is we can cooperate together between the public and the private sectors, and which part should be competitive areas in terms of SDVs. So next slide is autonomous driving. It is kind of exciting moment for Japan. We are finally moving on to the next stage, to the implement and the deployment of level 4 autonomous driving across the country, across the region in Japan. We are working very hard for research and development of automobile. Research and development for autonomous driving, such as 3D maps or new lidars and sensors and so on. We spend a lot of money from budget from the government as well. Now, like I said, last year we started the first cases, level 4 project started in Fukui prefectures. And now major Japanese OEM were working hard towards realization of robot taxis. As you can see, for example, Toyota, they are continuing to demonstrations across the region in Japan, and including here in Odaiba as well. And Honda and Nissan already announced to launch robot taxi services around 2026 and 2027. METI and related ministries have supported them to get approval smoothly, which are necessary for starting operations on public road. We believe that this digitalization trend has a huge potential as a game changer in the automobile industry. A company can make a profit from not only selling new cars, but In the future, after services, updating is more important. For example, advanced SDB can provide drivers new experiences that is resulting in the increasing the revenues. So major example is about taxis market. You can see the forecast, it's very high expectations, expanding the market very rapidly. So this is why many startups in the Silicon Valley and China and Japanese OEMs are working very hard to realizations and try to build the lowest business model of robot taxis. Digitalizations also have an impact of changing industrial structures as well. New players such as semiconductors, manufacturers, and suppliers, including Tier 1, Tier 2, Tier 3, and so on, will increasing their presence. And also entry of emerging IT-related and other industry manufacturers that brings an agile development philosophy to the automobile industry. And entry of service providers that specialize in providing content but do not manufacture vehicles have accelerated. As you can see on the slide, the previous slide and what's happening in the US and China in terms of digitalizations. Those innovations came from mainly emerging OEMs. It is because of zero-based development and the management mindset that allows aggressive investment that do not lead to the short-term profitability. They are the source of emerging OEM competitors. As for existing OEM, on the other hand, legacies such as supply chains and models in their existing businesses, causing them to make many adjustments and bottlenecks to rapid and innovation development. Next slide, it's a software human resources. One of the hardest challenge for Japanese auto industry is software resources. I know you guys are very expert in automobile industries, but from our estimate, approximately 20,000 software engineers at the macro level are expected to be short in 2025. It's kind of a old estimations, so it could be more now. In order to attract software engineers, there are several initiatives taken. For example, automated driving AI challenge is an initiative to discover outstanding human resources from different industries and doctoral graduate schools with advanced AI, IT technologies in the software field, including automated driving, and to promote the attractiveness of software development in the automobile industries. Participants compete to see how fast and safe they can drive on the specific course using open source software. In addition, METI established a field of automated driving in this skill course accreditation system, in which we accredit excellent educational courses. In cooperation with the Ministry of Health, Labor and Welfare, up to 70% of the cost of attending accredited course will be subsidized. Currently, 2 courses in the field of automated driving are accredited. A company will continue to expand the number of certified courses and improve the environment for the development of software human resources. Securing software human resources in urgent issues in order to respond to the future shift to SDVs and automated driving services. We will promote initiatives in the cooperative area, such as the development of skill standards for important human resources, the expansion of courses, and the expansion of basic human resources, as well as initiative by each company. Such a developmental skill specific to each company and partnership with external firms. At the same time, we will respond to the shortage of human resources by improving software, the usability, utilizing simulation environment, and otherwise promoting development efficiency and labor savings. We move on the data utilization. It is necessary to increasing the competitiveness of the automobile industry by integrally understanding, sharing, and utilizing data throughout the automobile life cycle from manufacturing to use to disposal in order to strengthen the supply chain and create new services, carbon footprint, inventory management, insurance, recycling. That kind of data could make a profit in the future. It is significant to expand use cases on the supply chain side, where needs are high, and then link them to initiatives on the value chain side in order to create and activate new data utilization businesses. As you can see on this slide, it is useful for automobile industry to start a data sharing to measure risk on their supply chain. Especially, there are three areas: improving resilience to emergencies such as earthquake, and second, early detection of defective products, and third, proof of product sustainability. I will explain later in detail about data infrastructures and use cases. Now let me show you an example of a value chain side. Due to the serious shortage of truck drivers in Japan, it is necessary to reduce labor and maximize this transportation volume. In order to solve logistics issues we face in Japan, the identification and standardization of logistic data items based on use cases, aiming for effective utilizations, starting with use cases such as safety and security, automation, electrification, also create standard API guidelines that can be utilized in other businesses. Now, let me show you what happened in the US. In the EU, both top-down initiatives based on EU regulations and bottom-up approaches based on the private sectors are being integrated to enhance the promotive power. These are intended to enhance sustainability and supply chain resilience, while at the same time minimizing business costs, promoting innovations, and improving industrial competitiveness. Catena-X is promoting an effort to safely link data through a federal-type infrastructure while ensuring network sovereignty and interoperability among digital platforms and realized operation of source code. Carbon footprint is a leading case, and they are considering to expand use cases such as recycling and product pass-through. We understand initially, Catena-X was mainly structured for German companies, and now they are expanding its participants, and Catena-X is enhancing its effort to reach out to Japan as well. And we are working and starting discussion now and in other countries as well. So next, let me explain those three main areas, which is key for global competitions in digitalizations. First pillar is SDGs. The concept of vehicle development and the design has been fundamentally reformed. Development man-hours have been drastically reduced and the speed has been improved. Not only changes in the vehicle structures, but also new values can be provided through software update, integrations with automated driving technologies, etc. International competition to secure competitiveness in the SDV market is accelerating, with semiconductor manufacturers and others entering the market from different industries. Second one is a new mobility services. Various challenges from slow mobilities to robot taxis are being taken up around the world. But my understanding is, unfortunately, so far, no successful business model has yet been established. In Japan, where the birth rate is declining, aging society, establishing a business model at the early stage could contribute to the solving various social issues in rural areas. At the same time, it could become new businesses that can be deployed around the world. Third pillar is a data utilization across the companies. Numerous data exist throughout automobile life cycle, from manufacturing to use to disposal. Integrated understanding of this data may lead to the creation of new value, such as strengthening of supply chains and the use of data in other businesses. In Europe, for example, Takeru, like I said, started its operations last year in order to build data collaboration infrastructures transcend corporate boundaries. EV battery carbon footprint is now first use cases. This could be a source of great value in the future from the two aspects. First, securing data collaboration infrastructures, and second, creating new businesses through effective use of data. So the bottom line is, in order to compete successfully, Japan will formulate goals and roadmaps to achieve them and mobilizing resources from public and private sectors. So this is an outline of mobility digital transformation strategies. In light of intensifying international competitions in mobility digital transformations, the current situation where following global players ahead of Japan, it is necessary to further strengthen public-private partnership in order to survive these global competitions. In particular, SDV development that each country has worked on independently, each company has worked on independently, will be positioned as a matter directly related to the competitiveness of the entire Japan automobile industry, and corporations will be promoted. In the end, METI announced this mobility digital transformation strategies on May 24th. So let me explain the definition of SDD. What is different SDD, by the way? Well, this is the hardest part for our interactive discussions of developing our strategies. Definition of SDD is various, depends on different experts and different contexts. During the process of development our strategies, we discussed the value provided by SDD first. As you can see on this slide, from OEM perspective, enhance development efficiency by separating hardware and software, flexible software design changes, and functional update after launch, various monetization points in collaboration with different industries, entertainment, interiors, charging, energy management, and so on. On the other hand, from user perspective, continuously updated with latest vehicle safety and operability features that customizable with additional features services. In order to materialize those values, the technological aspect of SDP is also very full. As you can see, the bottom on this slide, we define the SDP that the area circled by the red and blue dots. In addition, not only battery EV, but also all powertrains will be converted to SDVs. We would like to emphasize that it is important to aim for diversified SDV in terms of powertrains as well. Functions and price based on the target market and Japan's strengths. Our new strategy sets a target market share of 30% of Japanese affiliated companies in global sales of SDV as a goal of its initiatives in 2030, 2035. Like I said, we understand that Japan is lagging behind in terms of SDV development, so this number is pretty ambitious. As you can see on this slide, SDV market forecast is very hard to predict accurate. But based on interview with experts, we assume that SDV expand from battery EVs and luxury segment, and also assume that SDV expand various powertrains. This slide shows our goals and the roadmap to realize. So it's really a slide, so you don't have to read it. But through the implementation of mobility DX strategies, we aim to realize a safe and convenient transportation society and acquire added value in a new global market. In order to realize such a picture, it is important to widely deploy and promote Japan's diverse SDV with a range of functions and prices that can accommodate multiple market and users. In order to realize the 30% target in 2030, 2035, let me explain what we do in each pillar. So, developing our strategy, first we discuss with industrial leaders, academia, and experts how to identify cooperative area on technology cases. We set this criteria based on not only business perspective, but also industrial policy perspective. Based on this criteria, we identified a cooperative area of key SDV technologies. As you can see on this slide, which is pink, its cooperative area. Let me explain each technology. Well, first, semiconductors. Chip is one of the most significant parts of SDVs. It is necessary to integrate ECUs to facilitate software development and update it. And a high-performance system on chip is very essential for integrated ECU. While the design and the manufacturing of the high-performance system on chips is increasingly dominated by NVIDIA and Qualcomm and some other suppliers. Minimizations and specialized semiconductors for specific applications are essential to achieve both high performance and low power consumption. ASRIA, we call so-called ASLA. ASLA is established last year as a technological development association for cutting-edge manufacturing and cutting-edge SoCs. Next part is an API. This is where we have great expectations for all the activities. You all here today are experts on these issues. To accelerate development of SDB and enjoy its function very well, there are limits to the services that can be provided by each OEM alone. And services should be provided in cooperation with third parties in different industries. API standardization is gaining momentum globally. SDB Alliance was launched at CES in January of this year with a collaboration of Ultra, Cobesas, Sophie, Eclipse. There is also CAAM, that is Chinese initiatives. So METI worked very closely with JASPAR, Japan Automobile Software Platform and Architecture, to continue discussion towards API standardization. And next is simulations. In order to realize the efficient development environment, the conventional actual equipment process should be replaced with a simulation environment as much as possible. On this slide shows that development time period can be shortened by approximately 1 minute. The process and the assumed model for simulation utilization are organized into the following 3 points as the flow of V-shaped process from this slide. The first, at the design stage, between the OEM and the supplier, we will promote the construction of models for electric vehicles and autonomous driving, ADAS, which are not supported at present. The second, the bottom of this V-shaped process, we will promote the identification of actual status of model utilizations and organize issues for disseminations, taking into account specifically to small and medium-sized enterprises. We'll serve functional verifications, and the safety evaluation process. SDB can continuously update after vehicle sales, such as software update through OTA, are also important for coverage. Globally, based on Japan proposal, WP29 under United Nations is currently discussing the standardization of evaluations method that links simulation evaluations and actual vehicle evaluation. So, in order to increase development efficiency and speed, and to reduce the burden of evaluations, including vehicle and automatic driving system development, METI and related ministries will begin discussions this year on the ideal simulation environment and safety evaluations scenarios that can be flexibly used under various design concepts. This slide, generative AI. In the automobile field, there are various use cases for AI applications, including vehicle design, in-vehicle infotainment domain, recognitions and judgment in autonomous driving and ADAS, and construction of simulation environment to train such recognitions and judgment. Development and utilization of generative AI requires large-scale computational resources, supercomputers, and data. Globally, very small number of global players who can secure sufficient computational resources are able to develop competitive AI. Intensive support for securing computational resources for AI, which will determine the country's future competitiveness. So METI have 156.6 billion yen as supplemental budget this fiscal year, support computational resources for generative AI, including the automobile industry. Next, 3D maps. Currently, there are two technological approaches to automated driving. Navigation map plus certain information is added to the navigation maps, or high precision 3D maps. For example, Tesla, which claims to be mapless and takes off over launch. Japan has supported high precision 3D maps, but challenges with 3D maps are cost and infrequent updates. Therefore, we will demonstrate updating technology using probe card data, including detection of changing points and beyond, and develop the technology for its implementation. Next is a LiDAR. LiDAR has high resolutions, but minimization and cost reductions are issues. Research and development of new light source technologies, such as photonic crystal lasers, PC cells, is underway. PC cells is a laser in which photonic crystal laser is placed near the active layer that amplifies light. Photonic crystals with a microscopic periodic structures enable the generations of laser light with extremely high efficiency. So Japan supports so-called K project for research and development of these new types of LiDAR. The last one is security. Well, security is always important, but here we're not only talking about cybersecurity issues, but also data security. As SDD increasing globally, various data will be connected and exchanging across the borders. In addition of privacy, sensitive data may also be included. We are closely watching cross-border data regulations in China and ongoing discussion on data regulations by connected car in the United States. Last year, like I said, in Fukui Prefecture, its first level 4 project started its operations. Now, Japanese government, not only METI but also related ministries, work very closely, and also municipality towards realization of autonomous driving across the countries. And Kishida administrations set the target approximately 50 locations by 2025 fiscal year. New mobility service, including various technological tiers, from slow mobilities to robot taxis, the optional services varies according to local needs, demand, and characteristics, as well as the cost and the revenue structures. In this environment, we will actualize businesses that quickly respond to social need in terms of human flow and logistics, and develop advanced technologies such as robot taxis with the eye to the future. By around 2030, these results will be integrated to establish robust business models on various layers and contribute to solving global issues as well. In Japan, through automated driving and MARS, we aim to solve mobility issues in rural areas, traffic accidents that have emerged in the local communities, and realize new transportation society. Globally, we aim to lead the world by creating attractive mobility and new services. As all players are currently working on the development of automated driving, it is also important to first promote social implementation projects. In addition, we will continue to improve social acceptance and the environment by continuously disseminating information and fostering software-related human resources. In addition, while more advanced technologies require the realization of robot taxis, which may be commercially viable when combined with other services, will be strongly promoted to encourage the advancement of technology and the creation of services in Japan. Let me talk about logistics field. There are high expectations for self-driving trucks due to the serious labor shortage in Japan. Development of mass-produced vehicles is still in its infancy, and we will support the installation of automated driving functions by modifying commercial vehicles, aiming first at implementation on the new Tokyo-Nagoya expressway. Large-scale driving data acquisition will also be conducted and utilized for further development by manufacturers of heavy-duty trucks. Like I said, robot taxis are already in operation in the US and China, and if this trend continues, Japanese companies may lose its power. Therefore, by accelerating the development of self-driving systems in Japan, like I said, major OEMs aim to establish self-driving services that can compete with the rest of the world. My understanding, even overseas, the establishment of robust business models that can recover the huge investment has not yet been achieved. And competition is still underway. So, in Japan, different regulations and different ministries has rules in order to get permissions to start this operation on public road. This L4 committee is established last year. It is a one-stop service for robot taxi by all related ministries joining to get approval as soon as possible. Now, let me move on to the next one, the data sharing issues. In order to create new businesses and services through the use of data, it is necessary to promote efforts on the two fronts: the construction of data linkage infrastructure itself, and the revitalization of businesses that utilize data. METI established Uranus X system as mechanism for cross-border data sharing and system integration across companies, industries, and national borders. It is data coordination infrastructures that enable secure data exchange with players across the field. Last month, METI and Japanese auto industry leaders established Automotive and Battery Traceability Center, starting with operations of data infrastructures. Battery carbon footprint is a leading phase in order to comply with European regulations, like I said. It's a very busy slide. And we will use this knowledge to expand use cases in the supply chain, such as the calculation of life cycle assessments for automobiles, inventory management, production adjustment, based on the understanding of the contingency situation, and early detection of effective product. This fiscal year, we will start its demonstrations of data sharing. As a next step, we will expand our effort to expand use cases on the value chain side, which will lead to the provision of high-value added services to users and create and activate new data utilization business. This is the final slide of my presentations in Mobility Digital Transformation Platform. In order to implement these strategies, METI will establish new communities to visualize and disseminate various public and private sector initiatives, raise awareness and increase momentum of SDGs, and promote the acquisition and development of software human resources, promote information sharing and collaborations among companies, and study new initiatives. In particular, software development is an important element in the competition in a new field, and the development and the securing of human resources for software development is a common goal, global issue. However, Japan has not made sufficient effort in this area so far, so there is a notable shortage of software-related human resources. And promote initiatives such as the skill certification system for the purpose of human resources development and automated driving AI challenges, like I said, for the purpose of finding and acquiring of human resources. So I emphasize that many are very welcome from industry and organizations and experts overseas to join our initiative to work together. I conclude my presentation here. Thank you very much for your attention.